Impulse is kind of a cool thing. It's connected to Newton's second law. It's got two equations. I'm not going to give it a short form. I've seen some people use letter J. I've seen other people use letter I. I'm just going to write the word impulse. Impulse is force multiplied by time, or impulse could be the change in momentum. Depending what's given in the question, you'll either use the force versus time thing or the change in momentum thing. Kind of a standard thing would be a car crash or a ball getting hit, or the one I made up here is kind of a combination. Instead of a car crashing to a stop, it's a ball coming to a stop. In an impulse question, always kind of take a look and see what you're given. In this case, we're given quite a bit of kinematics information. That's a cue that we're going to solve this by using the change in momentum version of the equation. So for our baseball, we're going to use that impulse is change in momentum. Change in anything is always the final value minus the initial value. For this one, the mass is constant, so it's really the mass multiplied by the change in velocities, v2 minus v1. It's up there in the question, but our baseball's got a mass of 140 grams, which is 0.14 kilograms. The change in speed, it went from 50 down to 0. So 0 is our second speed, minus 50 as our second speed. You can multiply that out. That's going to work out to a nice clean -7. Impulse has funny units. It's kilograms times meters per second, or by kind of the magic of the metric system, that's exactly the same as newtons times seconds. If we're just dealing with impulse, that's the answer, -7, and then the units of either kilograms times meters per second or newtons times second. Often, though, we can use impulse to go a little bit farther. If we now know impulse and we're given a time that goes with that interaction, we can go one step farther and figure out the force. So to finish this one off, or to go a little bit farther, we know that impulse, that -7 number we just calculated, is also equal to F times t. For what we're doing now, think of this one as being in newtons times seconds. That'll help us with the seconds. When I wrote this one out, the time that I made up is probably on the big side, but I made up a time of 0.35 so that we'd have some nice clean numbers. When we work that through, we get a force of -20 newtons. In both of these answers, the negative is just to help us with the direction. The way it was worded, our baseball was moving 50, so impulse is a vector. The negative impulse, the -7 kilograms meters per second, or -7 newton seconds, the negative part just tells us it's in the opposite direction compared to the 50. Similarly, getting an average force of 20, the -20 tells us that it's in the opposite direction of the 50 of the initial speed. Note that this is an average force. If it was the same force for the whole 0.35 seconds, it would take 20 newtons. Probably it started off smaller, got much bigger, and then dropped off to 0 again, but we don't know if to figure out that peak force. We're just going to get the average force when we do this impulse.